Does that make any sense?
Yeah, I can see that.
All right, girls, we are.
Morning.
How are you?
Seem in a better mood today.
Well, things are starting to work a little bit better. That helps.
Oh, did you get my? I have a printer now. I can print it off now.
Okay. Well, what I'm going to do is I'm going to put. We're using OneDrive. I was initially going to use Dropbox, but we're going to use OneDrive. Do you guys know how OneDrive works?
No. Yeah.
Okay, good enough. You know more than I do then. So I'm going to put an assignment in there for you tomorrow. It'll be just a one-page assignment, and then I want you to put it back in. So we'll try and figure out how that's going to look and work, okay? Yesterday I went through that sum and difference identities. I'm going to go through this again, starting on page 200. So let's start on page 200. This is kind of why we're doing these identities. So I want to go through this. One of the major questions that we do is, okay, so this is yesterday what we did with, I showed you using sine 15 degrees. Well, this is the same idea. The cos is 7 pi over 12. It's not an angle that is on the unit circle. So I can't get the exact value of it. So what I'm going to do is I'm going to change it using my identity. So you want to have an identity sheet beside you when you're doing all of these questions. Keep that identity sheet beside you, okay? So either create one yourself or print the one off of the government website, okay? So the cos is 7 pi over 12. I don't know what the exact value of 7 pi over 12 is, but if I change it, actually I shouldn't use an equals here either, but if I change it, I can change 7 pi over 12 to 4 pi over 12 plus 3 pi over 12. That still gives me 7 pi over 12. All right. So then the identity for the cos of alpha plus beta. So the identity for it is cos 4 pi over 12, cos 3 pi over 12, subtract sine 4 pi over 12, sine 3 pi over 12. Okay, so the identity says that if I go cos alpha plus beta, it becomes cos alpha, cos beta, subtract sine alpha, sine beta. Now, the hard thing for people to understand, or what causes problems when we do these questions, is there's always going to be 2 or 3 people that multiply that through. That's not what it is. Okay, again, this is not cos times this. This is the cos of an angle. So the cos acts like a function itself. So I have to write it out as cos 4 pi over 12, cos 3 pi over 12, sine 4 pi over 12, and sine 3 pi over 12. Okay? Now, if I reduce those fractions, that is cos pi over 3, cos pi over 4, minus sine pi over 3, sine pi over 4. Okay, it's just by reducing 4 pi over 12 and 3 pi over 12. So now I'm into values that are on the unit circle. So let's use those values. What's the cos of pi over 3? One half. The cos of pi over 4? Root 2 over 2. Sine of pi over 3? Root 3 over 2. And the sine of pi over 4? Root 2 over 2. And now I've got 2 sets of fractions. This becomes root 2 over 4, subtract root 6 over 4. So the exact value of the cos of 7 pi over 12 is root 2 minus root 6 over 4. And this is why we use identities. We use identities to go from here to get the exact value of an angle not on the unit circle, not located directly on the unit circle. Okay. The next one. Tan of 165 degrees. Okay, so let's choose. All right, again, 165 is not one of those angles that I know. So let's choose two angles that I know on the unit circle. I know what 135 degrees is. All right, that's located on the unit circle. And I add that to 30 degrees. So now I look at my identity sheet. I look at my identity sheet to see what tan alpha plus beta is. And that works out to tan alpha, so the tan of 135 degrees, plus the tan of 30 degrees, over 1 minus tan 135, tan 30. Okay, now I'm going to take that off for 1 second. You should have your unit circle in front of you. 135 is right here. That is root 2 over 2, negative root 2 over 2, and root 2 over 2. So in other words, the tan of 135 is negative 1. Root 2 over 2, so tan is sine over cos, so root 2 over 2 divided by negative root 2 over 2. So the tan of 135 is negative 1. The tan of 30 well, the sine of 30 is a half. And I have to divide that by the cos of 30, which is root 3 over 2. So a half times 2 over root 3 is 1 over root 3. And again, because I'm in grade 12, I don't need to rationalize. I don't have to rationalize. So now I use those two values back here. Tan of 135, negative 1. Tan of 30, 1 over root 3. So I have 1, subtract negative 1 times 1 over root 3.
Brenda needs help to the office.
All right. So I'm going to clean this up a little bit. So that's negative 1 plus 1 over root 3 over 1 plus 1 over root 3. Now I'm okay at that point. At that point, I'm okay with this. The book, what the workbook would do to look, if you looked at the answers in the back of the book, is it would multiply everything by root 3. So I would times this by root 3, which gives me minus root 3. times this by root 3, which would give me plus 1. This by root 3, and that by root 3. So the back of the book is going to give you that as your final answer. So what I did is I multiplied everything by the denominator. So I times this by root 3, this by root 3, this by root 3, and this by root 3. But that's not my focus right now. My focus is, can you go from here to there? That's what we need to focus on. All right? Okay, so if you look on page 197, 197 gives you the 30 to 45 and the exact value for 60 as well. Gives you all those exact values. So I have covered the basic trig ratios, the sum and difference ratios. Today I want to look at the double angle identities. This is the last of them. Okay, these are the ones that are important. So I'm going to show you how they work, and they're the ones that you use the most. So for example, if I have an angle A, if I take the sine of twice that angle, that is the same as if I take the 2 times sine A cos A. This is what we call a double angle identity. Those give me the exact same value. So let me prove it to you. Don't have to write this out. I'm going to go like this. Let's let A equal 30 degrees. So I go sine 2 times 30. And then I go 2 times sine 30 times cos 30 over here. All right. That becomes sine 60, right? 2 times 30 is 60. What is the sine of 60 degrees? It's root 3 over 2. Okay? Now I go 2 times the sine of 30, which is 1/2, times the cos of 30, which is root 3 over 2. 2 times 1/2 is 1. 1 times root 3 over 2 is root 3 over 2. The sine of twice an angle is equivalent to going 2 times the sine of A times the cos of A. That is what we call the double angle identity. And this was just used to prove it. So for sine of twice the angle, there's only one identity. For the cos of twice the angle, there are 3 separate identities that you can use. And we use all 3 based on how the equations look. So the 3 for the double angle for cos are as follows. Okay, those are the 3 double angle identities for cos, and then there's 1 for tan. The 1 for tan is 2 tan A over 1 minus tan squared A. Okay, so those are the last of the identities that I needed to show you that we haven't got into yet. So what I want to do is let's have a look at question 2 on page 201. So let's look at question 2 on 201. All So it says, simplify, then give an exact value for each expression. So I have 2 sine pi over 4 cos pi over 4. So 2 sine cos pi over 4. So right now, I could actually, because I know what these are, I could just simply change these values and go 2 times root 2 over 2 times root 2 over 2. I could do that. That would give me, that cancels, that would give me 2 over 2. That would give me 1. All right? Okay, that would be the answer for it. But what they want you to do, and that's okay, because I know what the values of pi over 4 are for sine and cos. But what they want you to do is they want you to use an identity. So which one of the identities is 2 sine cos? Well, that's the same as going the sine of 2 times my angle, which is pi over 4. All right? So my identity is 2 sine cos. I can rewrite it as sine of 2 times pi over 4. That is the sine of pi over 2. And what is the sine value of pi over 2? To simplify it, change it to a single trig expression, and then simply use your unit circle at that point. All right? Let's look at 2b. I have cos plus sine sine. So I have cos pi over 3, cos pi over 12. Is that right? Yeah. Plus sine pi over 3, sine pi over 12, like that. So which one of my trig identities is cos plus sine sine? Cos, so I've got cos plus sine sine. That works out, that's the same as cos alpha minus beta, which is pi over 3 subtract pi over 12. And again, I can't substitute because I don't know what the value of pi over 12 is, so I'm going to make this into a form that will work. So this is the same as cos 4 pi over 12 subtract 1 pi over 12. If I get a common denominator, that's the cos of 3 pi over 12 3 pi over 12 is pi over 4, and the cos of pi over 4 is root 2 over 2. So I'm using an identity to change the form of it to make it simpler so I can go to an exact value. That's the whole intention of an identity, is just to make the question easier for you. Okay, let's look at C. Tan 80 plus tan 40 over 1 minus tan 80 tan 40. Okay, so we flip back to our identity. So I've got tan A plus tan B over 1 minus tan A tan B. That's the same as tan A plus tan B. So that is tan 80 degrees plus 40 degrees, like that. That's the same as the tan of 120 degrees. So let's look at my coordinates for 120 degrees. My coordinates are minus a half and root 3 over 2. Those are my coordinates for 120. So look at your unit circle. Now I take, excuse me, I take sine over cos. I end up with square root of root 3. That's my answer. square root 3. Okay, so far? The last one, 2 co-squared pi over 2 subtract 1. I can change that to the cos of 2 times pi over 2, which is cos pi. And what is the value of cos at pi? -1. So that question on page 201, so question 2 on 201, question 3 on 202, question 4 on 202, question 6 on 203, all of those are working with identities. I mean, they're all working with identities, but those are the ones that are probably the most important ones to look at. Okay? All right, so that's basically 6.2. Six 3 is proofs. Now, there's good algebra skills in 6-3, but if we were to write this provincial exam, I would 100% spend a pile of time on this. However, the need for proofs is not necessary beyond this class. So what I'm going to do then is I'll skip 6-3, even though I think it's one of the best things, but it's also one that causes a lot of problems. So let's have a look at, let's go to page 216. We're going to solve trig equations using identities. Okay, so go to 216 right now. Now, in grade 11, we took an angle like such as sine theta is equal to 1/2. Okay, so we wanted to find out, so this is in grade 11, we wanted to find out, okay, tell me on the unit circle where sine theta is equal to 1/2. So you'd say, okay, $30 degrees, 150 degrees. In grade 12, you would say pi over 6 and 5 pi over 6. And then in the last unit, we took longer equations. So we would take something like, all right, tan theta minus 1 equals -1, let's say. And then we solved it. So we got tan theta is equal to 0. So where on the unit circle was tan theta equal to 0? So you go theta is equal to 0, pi radians, 2 pi radians, and so on. And then we'd say, okay, well, it's at all of them. So I go k pi radians, k is an element of the integers. So far, grade 11 was this to degrees. Grade 12 was this to radians. And then last unit, we took an expression or an equation and we solved it and we got all our values that that it occurred over all real numbers, let's say, or general solution we call it, okay? We are going to do the same as that today, except we are going to change them using identities to make it simpler and then solve it the same way. So for example, look at page 216, example 1. I've got sine 2x plus sine x is equal to 0. All right? Now, the first thing that we need to notice is that our two angles are not the same. So we have to get them to the same. So now what I'm going to do is I'm going to look at my identity sheet. And how do I convert sine 2x? Well, I changed sine 2x. And what I would suggest is putting in brackets anytime you do a substitution like this. So I go 2 sine x cos x plus sine x equals 0. So instead of writing sine 2x, I've changed it to a single angle by making it 2 sine x cos x. Now I can't solve it again because I have a cos and a sine. So I look at this and I say, okay, I've got it equal to 0. So every time I've ever x cos x and sine x, okay? I can take a sine x out of them. So I got sine x times 2 cos x plus 1 equals 0. So I factor my sine x out. So now I have sine x equals 0 and cos x equals negative 1/2. So first things first. Also, I did have to look. It does give it to me between 0 and 2 pi. So where is sine x equal to 0 on your unit circle? Zero and pi. Where is cos x equal to negative 1/2 on the unit circle?
Um, 120 or
Yeah.
2 pi over 3.
2 pi over 3. Yeah. And where's the other one?
What am I looking for? Negative 1/2.
Where cos is negative 1/2.
4 pi over 3.
There you go. There's my solution. So I started this question with sine 2x plus sine x. And I found my solution to be 0, pi, 2 pi over 3, and 4 pi over 3. Okay? So the only thing that is new to you so far is converting from a double angle identity to a single angle. That's the only thing that you, so far, you've done from here down. You would have done this already. But just this part from going here to here, that's the only thing that's new. Okay? Let's look at B. Unless there's questions. You have questions about this? No? Okay. So let's look at B then. 6 sine squared x equals cos x plus 4. All right. So again, I can't work with sine and cos. So I either have to make them both coses or both sines. So here is the number one thing that you're going to find out, that you're going to use a lot. And that is this. excuse me. Cos squared x plus sine squared x equals 1. This is the Pythagorean identity, and you're going to use this a ton to convert, okay? I have sine squared x here. I have a cos x here, so I can't use them because they're not the same. So what I'm going to do is I'm going to change this. So sine squared x is equal to 1 minus cos squared x, like that. Okay? That's my Pythagorean identity. So now what I'm going to do is I'm going to substitute 1 minus cos squared x in here. So instead of having sine squared x, I'm going to write cos squared x in there. Now I am dealing with just coses. So I go 6 minus 6 cos squared x equals cos x, add 4. I'm going to add 6 cos squared x over to this side. And I'm going to subtract 6, so that gives me a minus 2. Okay, now I need to factor this. So I'm going to give you a different page. And ask you to factor it. Okay, because that's essentially what I'm doing. So my product, minus 12. Sum is 1. Factors, minus 3 and 4. Okay. 6a squared minus 3a plus 4a subtract 2. I did have it right. 2a subtract 1. Okay, so the factors are 3a add 2 and 2a subtract 1. Okay, so going from there, that gives me 0 equals 3a, oops. Three cos x plus 2 cos x subtract 1. Okay, so I factored it. That's what I'm left with. So again, all of this stuff is stuff we've done in all the quadratics that we've done up to this point. Now to apply it to your grade 12, here's what I have. Cos x equals negative 2 over 3, and cos x equals 1/2. So now I need to work with angles. 1/2 is on the unit circle, so where does cos x equal 1/2? One pi over 3 and 5 pi over 3. Okay. Now we need calculators. You have to change your calculator into radians. So this is what we did on the 2 units ago. So second function cos of 2 divided by 3. My reference angle is 0.8 2.841. Cos is negative in quadrant 2. .301, and cos is negative in quadrant 3 as well. So 0.841 plus pi. So that is the question with the most amount of work that you're going to have to do. Because you've got to, number one, you've got to use an identity. Number two, you have to factor. Number three, you have to find the unit circle values or use your calculator to do it. So there's a ton of work in these questions. All right. So we're going to skip over that 6.3. I don't like to do it because there's a lot of really good stuff, but you can get just as much algebra going through 6.4 right now on it. Okay, so I'm going to leave that today. What I'd like to see you do is get through 6.2, and then if you have questions, I'll answer those tomorrow. And then 6.4 we'll go through tomorrow, and I'll kind of give you another rundown on it. I'll do example 2 and example 3 with you. But that pretty much covers what we need to cover today on in this section. A couple things that you need to know, and you can pass on to others. I know, Daylin, you had mentioned to Rex that credit may not be there if he doesn't do the work. That actually is true. If your mark can't get worse, but if you don't do any of the work from here till the end of the year, you're not going to get the credit in the course. So that's something that you want to let everybody know in your class. I still haven't heard from a few kids, so make sure that if you guys are talking to others, to let them know that, okay? And what was the other thing? I had something else to tell you. I can't remember.
So in like physics, my mark won't get any proof.
Yeah, whatever that mark was at that point, but you still have to work through the rest of the year to get the credit in the course.
Yeah, I will, but like my mark can't get worse than an 87 right now, so that's kind of nice.
Yeah. Yeah, and I mean that's lucky because we only did the 1 or 2 assignments. So, okay, so that's all I've got for pre-calc today. We should maybe, running a little late to the conversation. Okay, I'm going to go through some physics with you guys right now. Okay.
I have to go get my phone.
Yeah. Mary, were you able to get that? I thought I emailed it to you yesterday.
Yeah, I got it, but I didn't get the chance to print it. But I can look at it on the iPad. Okay.
Well, I think I'll probably give you the most of the notes this morning anyway, so you may not need it right away. Did we talk at the start of this about the OneDrive, about using it? I think we did, didn't we? Okay, good enough. All right, so I'm just going to save this, and then I'll switch over to physics.
I don't know.
All right. You guys ready to go here? You probably want some paper. Okay, I'm going to, I just want to stop the live stream on YouTube, and then I'm going to start it again for physics.